Everybody, this is obviously on section 5.2 Arithmetic sequences. Just kind of very natural progression, I guess, like pretty easy build off of section 5.1. Definitely sticking with the whole sequences and summations of sequences, so series. But here we go. You might, well, I would bet that you have a lot of experience already with arithmetic sequences, and you just maybe never really knew that it was an arithmetic sequence. It could be called that. So here we go. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. So if you think about it, you've probably done a lot of those before. How about the sequence of 2, 4, 6, 8, 10, and so on. Or even the sequence of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. As long as you are always increasing by a common difference, is the official term, then it was an arithmetic sequence. 3, 6, 9, 12, 5, 10, 15, 20. But it doesn't have to be like that basic, obviously. I mean, you could increase by 3 and start at maybe 7. You could go 7, 10, 13, 16, 19. You know what I mean? So anyway, a few quick other examples that maybe you want to write down. If you want to write down some of the more basic ones like 2, 4, 6, 8, 10, you can also write those down. But this purple one, and I know I'm probably going, as always, a little too fast for you to kind of copy this stuff down, but in video form, as always, you have the luxury of pausing and going back and whatever. But so the common difference of this purple sequence, 142, 146, 150, 154, 158, and so on, the common difference, D, is 4. So become very aware quickly that the variable, the letter we're using for common difference, is the letter D, which makes sense, common difference. This blue sequence, -3, -2, 1, 4, 7, and so on, the common difference looks to be, what are we always increasing by? +3. And the last sequence here, 8, 3, -2, -7, -12. The common difference is actually -5. Yep, -5. Because it's like we're subtracting 5 to go from term to term to term to term to term. Or, adding a -5. So yes, common difference values can absolutely be negative. And that's a good example of one. Moving on, all you really have to do, if you're keeping good notes here, is what I've circled in yellow. That's all that really matters, is that a sub 1 is 51.5. And a sub n is a sub n minus 1 plus 2.18. Okay? So hopefully as you're writing that down, and especially writing down this a sub n part, I hope you notice immediately that this is recursive in nature. It's a recursion style nth term formula. Dead giveaway that a sub n minus 1's in there, because as I'm trying to make clear in class and on the previous video, I would imagine, a sub n minus 1 you should just think of as the previous term. So this is, the nth term is based on the previous term, the n minus 1 term. So what that means is, even though you could technically plug in 2 to find the second term, which makes that a sub 1, and plug in 3 to get the third term, which makes it, 3 minus 1 is 2. And plug in 4 for n, and so on and so. What really is happening is this a sub n minus 1 just becomes the previous term. So to find the second term, it just ends up being the term before it plus 2.18. And the third term ends up being the term before it, 53.68, plus 2.18. And so the next time we're going to plug in 55.86 to get that. And then the next time we're going to plug in 58.04 to find the next term, because the next term is always based on the previous term. And now look, another thing as you finish writing all this down, another thing I hope you notice is that not only is this recursive in nature, being based on the previous term, but what this basically says simply is that the nth term is just the previous term plus 2.18. You're just going to always keep adding, that's it. You're just going to keep adding 2.18 to the previous term, which makes it also not just recursive in nature, but arithmetic in nature, because all you're really doing is adding 2.18 every time. Here's the first term. You just add 2.18 to get the next term. Then you just add 2.18 to get the next term. Then you just add 2.1. You just keep adding 2.18. So yeah, the common difference, there is one, and it's 2.18. It's, I know it's a little bit mysterious. It's not blatantly obvious with it being in this recursive style with the a sub n minus 1. It's not blatantly obvious, but it's definitely arithmetic. What if I told you, hey, there's this sequence, this arithmetic sequence where a sub 1 is 10. What if I told you a sub 1 is 10 and d equals 4? So a sub 1 is 10, d, the common difference, equals 4. And what if I wanted you to list the first half a dozen terms or so? Wouldn't that be real easy? Just, okay, so 10, and then 14, and then 18, and then 22, and then 26, and then, 30, right? Hopefully I didn't make any mistakes there. But so again, all you do is just keep adding 4, starting with 10. 10, 14, 18, 22, 26, 30, and so on if you had to keep going. So that's what's kind of happening here. So anyway, a lot of writing here, but at the end of the day, this is a very, very simple, listing of terms based on that it's really just arithmetic. Okay, to fast track this a little bit, I don't know, maybe not. We'll see how this goes. But what if we wanted to investigate how to find any term in an arithmetic sequence? What if I wanted to jump ahead and find the 18th term, or the 58th term, or even the 108th term, or the 109th term, whatever. What if I just wanted to skip ahead? What if I knew the first term, a sub 1, and d, the common difference? What if I knew both of those? What if I knew that the first term was 10 and the common difference was 4? So it went 10, 14, 18, whatever. But what if I wanted to skip ahead to the 109th term? How could you do that quickly, right? Is there a shortcut? Is there a formula? Foreshadowing there. So anyway, a quick investigation. Obviously, a sub 1, the first term was just a sub 1. And to get the second term, you add d to that, so getting the second term. But the third term is a sub 2 plus d, so in a way, a sub 2 was a sub 1 plus d. So at the end of the day, you could say that the third term is the first term plus 2d. Make sense? So we have, this is a sub 1, this is a sub 2, and this is a sub 3. And maybe you see a pattern forming already. The fourth term would be a sub 1 plus how many common differences would we have to add to get to the fourth term? Well, it would only be 3, right? And the fifth term would be the first term plus 4 common differences, 4d. And I hope now the pattern is really obvious. And all this is really doing is sort of like a build-up, kind of like an investigation to, all right, so in general, the nth term would be this. And what I'm going to do actually here is include a sub n equals out in front. So the nth term is going to be equal to the first term plus n minus 1 times d, because again, n is the term we're finding, and if I wanted to find the 100th term, like if I wanted to find a sub 100, it would be 100 minus 1 right here. I would only want to add 99 common differences, 99, d values. So that's why this n minus 1 is here. But anyway, I hope you understand the formula. It's not that tough to wrap your brain around, but the bottom line is this is the formula, and you want to keep this in your back pocket. And FYI, oh yeah, shout out to the soundtrack. But anyway, like I was saying, you don't have to memorize this per se. You're gonna have a formula sheet on the eventual test, but just because you don't have to memorize it, you definitely should become very familiar with it, know what's going on with it, and understand how to use it, and yada yada yada, right? So moving on. Just a quick example. Find the 8th term of the arithmetic sequence whose first term is 4 and whose common difference is -7. So, it's arithmetic, right? And we want to find the 8th term. So, I don't think we're desperate for a formula. I mean, it's only the 8th term. I mean, it wouldn't be that tough to list all 8 terms to get to the 8th term, but let's use the formula, right? So we're going after a sub 8, aren't we? So a sub 1 is what? What's a sub 1? Hey, they told us that for free. A sub 1 is 4. And then we already know that n is what? N is 8. If we're going after the 8th term, that means n equals 8. And what are we going to plug in for d? D's the common difference. They told us that for free. And so the common difference is -7. So that's how we plug into the formula. We're finding the 8th term, so that's n. A sub 1 is the first term. They told us that for free. D is the common difference. They told us that for free. So from here, it's just a matter of letting the numbers do their thing. Make sure you're doing the correct order of operations, for crying out loud. You know what I mean? And that's how this proceeds, I guess. 8 minus 1 is 7. You do that first. Then you multiply. Then you do the 4 plus -49. Adding, subtracting, whatever the heck you want to call it. Just do the operations in the correct order. And because, look, formulas are guaranteed answers as long as you're plugging into them correctly. Moving on. No screwing around this time. Let's just cut right to the chase. This is another important formula to put in our back pocket. This formula will tell you the sum of the first n number of terms in an arithmetic sequence. Has to be an arithmetic sequence. but this is how it's done, right? So n is going to be how many terms we're adding up. A sub 1 is obviously the first term. A sub n is going to be what, people? What are we going to plug in for a sub n? I mean, you can feel free to plug in, again, like, let's say we're finding the sum of the first 50 terms. Then n is 50, so I guess that would become a sub 50. So like the 50th term, okay, which in general, okay, is always going to mean the last term. So whereas a sub 1 is the first term, whatever it is, a sub n is going to be the last term. So let's see how this works. Find the sum of the first, now we're talking the first 100 terms. See back here, finding the 8th term, I mean, it would have been probably a much more realistic example, or I don't know, like a valid example. I don't, again, like I said back at that time, it's not like we were super desperate needing a formula to find the 8th term. Maybe this example would have been a little bit, I don't know, better of an example to find like the 88th term or the 800th term. But anyway, so now we're talking the first 100 terms we're adding up. Way more obvious that we need a formula to do this. And it is going to be an arithmetic sequence, so we can use the formula. And the sequence goes 1, 3, 5, 7, and so on and so forth, forever, basically. But we just want to find the sum of the first 100 of them. So n, what are we going to plug in for n? Well, obviously it's 100. We're finding the sum of the first 100 terms. And a sub 1 is the first term, which the first term is 1. How about that? But a sub n is a sub 100. And this is where I want to pause for a breath because people get mixed up here, okay? A sub 100 is not 100. We're not doing 1 plus 100. A sub 100 is the 100th term. It's not 100, it's the 100th term. It's a sub 100, sub 100. So what's the 100th term? I don't know either right now. And maybe that's why people have extra reason that they fall into that mistake. They just assume, oh, I'll just do 1 plus 100. Because I don't know the 100th term right now either. But I sure as heck can figure it out, even if it means literally using that other formula. Okay? So, yeah, I might have, like, that's what I'm going to do. I'm going to go off on the side and use the other formula to find the nth term, and I'm going to find the 100th term by adding, essentially, 99 common differences of 2, because that's obviously what the common difference is, 1, 3, 5, 7, 9, 11. We're just always increasing by 2. And so the 100th term ends up being 199. And now we can finish off the formula. Make sure to follow the order of operations, for goodness sake. And so the final answer is 10,000. Okay? Moving on, I guess, but pause the video if you didn't finish writing all that down. Anyway, one more example. Find the following sum. And it's given in sigma notation. So we want to find the sum from 1 to 25 of 5i minus 9. Okay, now 1 to 25. if you're thinking that we're going to do this by hand and manually find all 25 terms and add them up the long way, I guess that wouldn't be the worst thing in the world, but bad enough. Like, we are not going to do that. I'm not going to find all 25 terms by plugging in 1, then plugging in 2, then plugging in 3, then plugging in 4. Not going to find all 25 terms, especially considering that that could have been a lot higher than 25. That could have been like 250, theoretically, right? And I'm not going to do it, for more than that reason. It turns out that this represents an arithmetic sequence, an arithmetic series also, right? With it being a sum. But this is representing an arithmetic sequence. How do I know that? Well, someone like me with years of experience, I just happen to look at that and go, that's arithmetic. But there's nothing wrong with doing a quick, investigation, looking at how the first term is -4 by plugging in 1. The second term is 1 by plugging in 2. Third term, plug in 3 to get 6. So a quick check, just verifies what I already knew with my years of experience, that this 5i minus 9 in the sigma actually meant that it looks like it is arithmetic. And what's our common difference? -4, 1, 6. Our common difference is 5. And what that really means to us is that we can use the formula. And so we use the formula. Okay? And you can save yourself most of this work here in the future by simply, learning by experience and stuff that 5i minus 9 does represent an arithmetic sequence. Or heck, maybe the directions will be kind enough to literally say that the following sum, and this is maybe it'll say that it's arithmetic in the directions. But, and by the way, coincidence that the common difference is 5, Coincidence that the common difference is 5? Seeing as how there's a 5 right there. Coincidence? I think not. Anyway, my n value is what? Now I'm going back to my formula. Here we go. Let's really get going on this. My n value is 25 because I'm adding the first 25 terms. So there's 25. A sub 25, right? The 25th term. I'll get to that in a second. The first term is what? How do I figure out the first term? They didn't... Okay. Sorry again. They didn't tell me the first term for free, so... But I did plug in 1 over here to figure out what the first term is. So that's what you do in this situation. You can just plug in 1 to get the first term, which we already did right here, -4. And how do I get the 25th term? The last term. Well, I could do this same sort of thing, potentially, but guess what? In this specific situation, all I have to do is plug in 25 in this particular situation. And what I get is 116. So now I can plug that in for a sub 25 and just let the formula play itself out and get 1400. And that's that. So once again, important to see the comparison in these two examples. Here, based on how they presented the information, where here they gave me 1, 3, 5, 7, yada, yada, yada. you pretty much had to do this thing to get the last term. But in this situation, all you really had to do was plug in 25. And just also keep in mind that now we have a couple major formulas in our back pocket, at least for arithmetic style sequences and series. This formula for the sum and this formula for the nth term. And that is section 5.2.